Dear 9th class students, now in this next topic we are going to discuss about properties of parallelogram. The first property is a diagonal of a parallelogram divides the parallelogram into two congruent triangles. So given is quadrilateral ABCD is a parallelogram. Second given is AC is its diagonal, one of its diagonal. What is required to prove? Triangle ABC is congruent to triangle ACD. So now we are going for proof. Now proof. See, AB is parallel. See, ABCD is a parallelogram, so opposite sides are parallel. Two pairs of opposite sides are parallel. So, proof AB is parallel to CD. Opposite sides of parallelogram. And AC is transversal. Okay, this is transversal. So this angle would be equal to this angle, alternate interior angles. So angle BAC is equal angle DCA. Angle BAC is equal angle DCA or angle ACD, you can say even ACD. Did you understand? Right. Now these two are parallel. AD is parallel to BC. So again opposite sides of parallelogram, and again AC is transversal. Okay, are you following? AC is transversal. So you can say that this angle equal to this angle, because again the same reason, alternate interior angles. So angle DAC is equal angle ACB, okay, or angle AC, are you following? No, angle DAC is equal angle ACB, again same reason, alternate interior angles. Now in these two triangles, now in triangle ACD and in triangle ABC, you can see that, okay, angle DAC is equal to angle ACB. Just now we have proved. Okay. AC is equal AC, common side. This is proved. This is common side. Okay. Next, angle CAB is equal angle DCA. This is also proved. So ASA congruency formed. Therefore triangle ABC is congruent to triangle ACD by ASA congruency criterion. So the diagonal of a parallelogram divides the parallelogram into two congruent triangles. Dear students, our next second property is in a parallelogram, opposite sides are equal. So given quadrilateral ABCD is a parallelogram, required to prove opposite sides are equal. That is AB is equal to CD and AD is equal to BC. That is required to prove. Proof. Now proof. AC is diagonal. of parallelogram ABCD. Therefore, triangle ABC is congruent to triangle ACD by a proved theorem. Just you have to write that theorem statement which we have proved in the previous context. The diagonal of a parallelogram divides the parallelogram into two congruent triangles, that you have to write. So as these two triangles are congruent, triangle ABC and triangle ADC, as these two triangles are congruent, so you get AB is equal to CD by CPCT. Again, now you take BD diagonal. BD is another diagonal. BD is another diagonal of parallelogram. BD is another diagonal of parallelogram. So therefore triangle ABD is congruent to, are you following? Triangle BCD. Again using that same theorem which we have used here. As triangle ABD is congruent to triangle BCD, okay, AD will be equal to BC by CPCT, and hence in parallelogram opposite sides are equal, has been successfully proved. Dear students, the converse of this theorem is also true. Okay, what do you mean by that? If in a quadrilateral each pair of opposite sides are equal, then it is a parallelogram. The converse is also true. Please note this point. Converse of this theorem is also true. That is, in a quadrilateral, if each pair of opposite sides are equal, then it is a parallelogram. Dear students, our next property is the diagonals of a parallelogram bisect each other. The diagonals of a parallelogram bisect each other. So what is given? Okay, quadrilateral ABCD is a parallelogram. AC and BD are its diagonals, and these two diagonals are intersecting at O. So required to prove they bisect each other. That means OA is equal to OC, OB is equal to OD. Now proof follows. Now we are going to prove this theorem. See, if you consider these two parallel lines and this transversal, obviously this angle equal to this angle, alternate interior angles. Are you following? Now if you consider these two parallel lines and this transversal, okay, this angle, okay, are you following? This angle would be equal to this angle. Are you following? So these two parallel lines and this transversal we are considering, so this angle equal, alternate interior angles. Okay, now we are considering these two parallel lines and this transversal, so this angle would be equal to this angle, again alternate interior angles. Did you understand? So same reason you have to express. Okay, so I am not writing all that, but whatever the reason I told, you have to write in the examination. Okay, now I am writing directly that, okay, triangle OCD is congruent to, okay, triangle OAB by which congruency criteria you are seeing? Two angles and included side. Okay, or else you write, okay, let us write to avoid confusion from any angle. See here, elaborately I am writing, in triangle OCD or COD, your wish. In triangle COD and in triangle AOB. So what you are seeing, angle OCD is equal to angle OAB, alternate interior angles. AB is equal to CD, opposite sides of parallelogram. Next, angle ODC is equal to, are you following? Angle ODC is equal to angle OBA. Again, alternate interior angles. Therefore, triangle COD is congruent to triangle AOB. Triangle COB is congruent to triangle AOB by ASA congruency criterion. As the two triangles are congruent, so therefore OB is equal to OD by CPCT. Similarly, it can be proved that triangle, are you following? Triangle OAD is congruent to triangle OBC. Therefore, OA is equal to OC, CPCT. Hence, the diagonals of a parallelogram bisect each other is successfully proved. Dear students, our next property is, in a quadrilateral, if a pair of opposite sides is equal and parallel, then it is a parallelogram. So given in quadrilateral ABCD, AB is parallel to CD and AB is equal to CD. This is given. What is required to prove? ABCD is a parallelogram. So construction is draw the diagonal AC. Now proof follows. Okay, AB is parallel to CD. So given. So AC is transversal. Obvious. Then this angle will be equal to this angle. Alternate interior angles. So angle DCA is equal to angle BAC. Alternate interior angles. Angle DCA is equal to angle BAC, alternate interior angles. Did you understand? Okay, now compare these two triangles. Therefore, now in triangle ACD and in triangle ABC, triangle ACD and in triangle ABC, are you following? CD is equal to AB given. Angle DCA is equal angle BAC, just now proved. AC is equal AC, common side. Therefore, triangle ABC is congruent to triangle ACD by SAS, side angle side. SAS congruency criterion. Two sides and included angle of one triangle are respectively equal to two sides and included angle of the another triangle. Then those two triangles are congruent by by SAS congruency criterion. SAS congruency criterion. So the moment these two triangles are congruent, okay, by CPCT we have, are you following? So by CPCT we have angle ACB is equal to angle CAD by CPCT, which are alternate angles. Are you following? Therefore, you can conclude that AD is parallel to BC. Given that AB is parallel to CD, now we have established AD is parallel to BC. Then the two sides, the two pairs of opposite sides are parallel. Then it is a parallelogram. This is the conclusion. Understood?